In this session, we are going to discuss about that chapter 3 in VMM. What is that? Assertion. Okay. So we know about OVL verilog assertions and then system verilog assertions. Okay. Now this we know that this VMM is fully discussed with respect to system verilog and some common aspects of verification, right? Okay, now we are going to discuss about this assertion in detail in this chapter. So first, what we are going to see, first we are going to see about specifying assertions. Okay, next assertions on internal DUT signals. So we know that assertion we can write assertions on inside a DUT as well as in the verification environment, right? So first we are going to see about that assertions on internal DUT signals. Next we are going to discuss about assertions on external interfaces. Okay. Fourth we are going to discuss assertion coding guidelines. Then last we are going to discuss about reusable assertion based checkers. Okay, so this is what the agenda of this chapter, assertions. Okay, so shall we start this discussion? Okay. Concurrent and immediate assertions are an integral part of system verilog. They provide an effective way to improve observability and localization of design errors by placing functional check at critical points inside a design and on external interfaces. So we know that overall we can place our assertions inside a DUT and the external interfaces side. Okay, so by writing this assertion, what will happen? We can improve our observability of our design, right? That means what? It will indirectly reduce your debug time. Suppose verification engineers find some bug in your DUT, in your design. Okay, so it is very easy to trace that bug by writing this assertion. And one more thing, concurrent and immediate. In a system verilog we know that concurrent and immediate assertions, right? Concurrent assertions, we can generally say that concurrent assertions will have the reference signal as a clock, and immediate assertions is like combinatorial assertions, right? Whenever the particular event triggered, then that assertion will get start to evaluate the assertion check. Okay, so when an assertion fails during simulation, the cause of the reported error can be more easily identified than by observing simulation traces. And what they are trying to say here means, suppose assertion fails. Okay, so in the very in the very near proximity, it will tell you what is the error and because of what the error has occurred. Okay, so by using that we can predict where the bug is, right? And look at here, concurrent assert property. Look at the concurrent assert property statement can also be proven or falsified using formal tools, thus further increasing confidence in quality of the design. We can use the same assert properties inside a formal tools. Okay, we know that the formal tools are also having the mathematical kind of things to check the functionality of our design. Okay, so we can use the same property in a formal tools, thus further increasing the confidence in the quality of the design. Finally, coverage properties provide information on how well the design has been functionally exercised during the simulation. That's clear, right? So by using that coverage properties, we can decide how well our functional our design is functionally exercised, right? So this chapter first introduces system verilog concurrent assertions and their possible uses. Okay, then this introduction will be useful to readers new to the notion assertions. Okay, first we are going to discuss about system verilog concurrent and their possible uses. Next in this chapter, what we are going to discuss, role of assertion on internal signals and interfaces of a design. Okay, this will be useful for designers because it requires detailed knowledge of the design. Assertions on external interfaces useful to both verification and design engineers. So we can classify this chapter into three. Okay, first we are going to discuss about the system verilog assertions introduction. Okay, then how the design engineer can write assertions inside their design as well as the at interfaces side. And what about verification engineers? They also will write the assertions at the interfaces level. Okay, so at last this chapter will going to present some guidelines for writing efficient assertions, coverage properties, and the guidelines and techniques for packaging assertions into a reusable checkers are also presented. Using checkers simplifies the process of adapting assertions. Checkers can be divided into two broad categories. What is that? Basic checkers and assertion based verification IP. Look at there. Checkers can be classified into two things. First, basic checkers and assertion based verification IP. Basic checkers will be interest to anyone who plans to use checkers to develop new ones. Okay, the section on assertion based verification IP is mainly directed toward developers of such IP. So at last in this discussion we are going to see about how to verify assertion based checkers. Okay, so this is all about the outline of this discussion. Okay, how the designer can write the assertion, how the verification will write the assertions, and then guidelines to make the assertions as a reusable component, and then assertion IP, assertion verification IP.